Hey everyone, welcome back to our developer tooling series. And today we are joined with Joe, who is part of the Onzo tooling team, who created a new tool that we're going to be chatting about today called Mollusk. And Joe, would you want to introduce yourself?
Hey guys, Joe. Yeah, like Bree said, I wrote this little testing tool called Mollusk, and it lets you test Solana programs and just kind of like work more directly with the VM. I work on like a lot of the runtime and on-chain program stuff at Onza, so this is something that we needed and we use. And if you guys want to check it out and use it as well, I encourage you to do so. And we're going to show you how.
Awesome. So before we get started on some live coding through testing out this tool, could you just give some context on why you made the tool and also like how this is different than other testing tools that are available today?
Yeah, so to be clear, right now, there's like a few testing tools that are pretty good. And like a lot of people have different use cases for different tools. I'm not saying Mollusk is like the be all end all, but there was obviously a lot of issues with Solana program test.
Yeah.
And everyone kind of has heard some of these gripes before. And it, like, to be frank, it didn't really get a whole lot of love. But one of the main things is that it would bring with it like a ton of stuff. So the idea behind program tests is that it would give you an emulated cluster, like a very minified sense. So you'd have like a banks client, you'd have like an actual bank. So you'd have like a runtime, you'd have like persistent state and all this other stuff. And it turns out that like when you're testing a program for 90 to 95% of like test scenarios, you really just need to know like what is my program going to do with this set of inputs and what are the outputs that it's going to produce. And it turns out that you don't really need to know anything else about the network. And so my thought was like, all right, can we build a test harness that does just the lowest level thing that the Agave validator does? Can it spin up a VM? Can it give it the inputs that it would get in a live scenario and then just return the outputs as is? And the developer can do whatever they want with that information. And the answer is yes. And it actually ends up being very fast and opens up a little bit more creative liberties, let's say, for like testing different scenarios, right? Because when you have like the whole runtime baked in, like it's hard to kind of like modify the behavior of whether it's like the VM or whatever the case might be. When it's just a few components, you can do a little bit more.
Yeah, that's all.
Let's just test programs and also lets us test like potential changes to the protocol, which is cool.
That's really cool. So let's dive in and test it out. Do you want to show us Mollusk and what your example is?
I haven't live coded in a while. That's what we're going to do today. So let me share my screen. And what I'm basically going to do is I'm going to write like a really simple program. And we can set up just a super like dummy simple. I'm going to write it in native, but you can do it in whatever like framework or no framework that you want. It doesn't really matter. So like Mollusk is agnostic to all of that. Okay. So for all those of you guys who are interested in my little like template generator, I don't expect you to be interested. You probably just don't really care, but it just generated like a bunch of placeholder stuff for us. It's just like a bunch of like boilerplate that we can use to write a native program.
Perfect.
If anybody watches this video and they think this is cool, you can at me on Twitter. Maybe I'll publish it, but I just wrote it today.
Cool. Well, Twitter handle on all the screen here, so
Yeah, I could be.
can find you.
Could be. Yeah. So I want to make like a mini order book and I'm not going to do like everything that an order book would have. So I'm not going to do like, settlement or anything. I'm not going to do any of like the fun stuff. Just going to use it as an example of like creating some state and having like a few checks and we'll test those things out. And then we'll see about like maybe playing around with some of the additional complexity that you can test with Mollusk. So let's just say like, we're not going to do too much documentation here. So we'll just say like create order, create order, and we will do create bit and I'll make this serialization pretty simple. See if Copilot will help me crank this out for the purpose of these videos. That would be great.
Love Copilot. It's good help.
Yeah, it'll help us here not waste anybody's time. So cool. We'll come back to this if you want to add some input data, but the whole idea is that we're going to basically have this like process, create, order. And this is like boring stuff that everybody knows. We will, yeah, there you go, Copilot. Nice job. Okay, so let's look at some state. This is not anything that has to do with Mollusk, so I'm going to kind of blow through this really quick. I could have got some of this prepared ahead of time. So I'm going to just say like ask 264. And for the sake of this like example, I'm not going to worry too much about what the assets are. Let's imagine there's some asset that people are listing with an order. Let's say it's like a token of some kind, and the bidders are going to bid SOL. They're going to bid Lamports. Okay, so I'm going to just do like ask and like size, right? And that's really all we're gonna do. It's gonna be not the most secure order book ever, but it is what it is. So as you can see, the bid too, like ask and then bid. This is pretty good for me. Okay, so I think we'll probably have to take in a couple of parameters. So we'll just say like ask and size. Let's keep this guns. And I'm assuming this one that will use parameters, which is too bad. Should be able to crank this out. Nice job. Then I'll just go ahead and say find these little instruction helpers. So I'll just say like order turn instruction. It's probably like nauseating to watch this. If you're like watching all the things that this AI generates, it's kind of drives me crazy too. Don't worry. I guess we'll just say like order count and we'll say ask and size. And let's do one for the bid as well. Yeah. And then I'm gonna be like pretty simplistic here with the processor. So the first one, I'll implement each of these separately and then I'll like write tests. So, and then we can start talking about the actual tool. And in case you were interested in like cutting most of the setup out, you can. I'll just look at the program right here as like a recap. So we got this little mini order book program that we were talking about, and we're going to implement these two processors and we're going to test them. So it's pretty simple order book. We're just creating an order and a bid. The bid's going to be on the order, and we're going to just require each account. So I guess I'm going to also add like the order address here, and I'm going to just like change this to include both accounts. Okay, and pretty simple. We're going to expect that these accounts are already like allocated assigned, and we can talk about that as we go. So anyway, what I usually do when I write mouse tests is I do include a test folder. The nice thing about Mollusk is like technically you don't need to do it this way. You don't even need like test SPF. It's just easier because test SPF will generate or it will populate the like SPF out directory variable, environment variable, which is this little folder here. So like when you use the Solana platform tools and you like use the cargo subroutine and you build a program, cargo build SPF, there's a variable here that will tell it where to put your compiled program. And Mollusk hijacks that variable to look for programs to read. So you can just give it to it manually, or you can just like wrap all your tests behind test SPF, which is what most people do because they don't have to worry about it. So I'm just going to do it that way, but you don't necessarily have to do that. So we'll just cool. So we're gonna write this like little simple like minified order book, and like I said earlier, we're not gonna do any of the like settlement stuff. We're just gonna do creation of like two forms of state. So we'll create orders. We're gonna expect the order account to be already allocated and assigned, so we can initialize the state. And then same thing with the bid. We're gonna expect the bid to already be allocated and assigned, and we're also gonna expect the order to be initialized. And obviously, you'll have like the ID here that responds to which one that you're bidding on. And so here's our state. I will also go ahead and add the order. This. And then this is kind of how our little program is going to work. And so I'll show you guys how to test this thing. But first of all, we need to actually write some processor implementation. So to create an order, let's just say like that order account. I was going to say we're info equal accounts dot first. Okay, or I like Max Payne. So I type this all out.
Nice.
It was already in the port. No. Really testing my live coding skills here. Not bad, right?
Oh, you're killing it.
Cool. All right. So we are going to load our order account in, and the order account should have already been allocated and assigned. Okay. So if the order info dot owner is not equal to program ID, we're going to return, let's see, invalid account. And we'll come back to this. But let's just test to make sure that this check works. And we'll use Mollusk. So like previously we had all these different like things that we had to do to set up a program test. What we're gonna actually do is I'll go ahead dev Mollusk SVM. And you'll see just exactly how easy it is to do with Mollusk. So here's the dependency. And we're going to just go ahead. And I was mentioning this earlier, but you don't have to use the test SPF feature. The Solana like subroutine in Cargo, like when you do Cargo build SPF or test SPF, it looks for this feature and it activates automatically because it will populate an environment variable that tells Cargo where to find your program binaries in here. So you can just like provide this manually to Mollusk if you want, but if you don't want to, you can just like put this behind the test SPF feature flag, and you can just run cargo test SPF, and it's just gonna do it for you. So anyway, you can just import Mollusk. I'm also gonna import like a couple of other things that we might need, like account. So like these three things are kind of what you need for working with Mollusk. And as you can see, I haven't included it yet with the account one. That's like the three main types that you kind of need. You can do a little bit more than that, but you are going to work with mostly accounts, pub keys, and then like the Mollusk harness. And that's like the whole point of the tool is that you're going to give the program only the inputs that it's designed to work with. So like this function right here is kind of going to look pretty similar to what Mollusk is going to like give the harness. And you'll see exactly what I mean. But the whole point is like, I only care about what the inputs to this program are. And there's really only like three inputs that you care about besides like any of the registered syscalls. It's going to be the provided accounts. It's going to be the input buffer, and it's going to be the syscalls or the sysbars. So the sysvar accounts that exist on the chain. And Mollusk lets you modify all three of those. So we'll write a test and we'll just say like test create order. And we're going to say let mollusk equal mollusk new. And you can see that it's going to expect a program ID and a program name. Now, this is just like a shorthand function, new, that's going to basically load in your dependency, your program. And I don't have my analyzer pimped out like a lot of people do, but you can see here that it's just going to like create the default setup and it's going to add a program and then it's going to return you the mollusk thing. And going through this entire stack is not all that exciting, but ultimately at the end of the day, what it will do is it will load your program elf from just like a file and it will load it into this like little program cache that it has that mimics the one that's in the actual program runtime. And so the point is like, if you add a bunch of programs to the test environment, that you can just reuse the same Mollusk instance and it'll have them already. And since we don't really care what the program ID is, we're just going to make a new unique program ID. And I think I called this mini order book, right? So you just want to take a look at what's in here, mini order book.so. So we're just going to tell it to look for mini order, and that'll load in the program and give you a Mollusk instance with the program that you built in the cache. And then you want to go ahead and say, let instruction. And we wrote these little helpers in here to create these instructions for our program. So I'm going to use those. So I'm going to say like mini order book instruction, create order. And then I'm going to just do create order. We got the program ID. We need an order address. So we'll just set up some keys. And we need, everything's going to be a reference, big reference guy. For like ask and size, I don't know. I don't really care about these values right now. So I'm just going to like set them both to like 100. Sure. And then accounts. So this is like another, like we're setting up right now are the inputs. So obviously everyone knows that like you got to create an instruction and like typically you would go create a transaction with this. You would send it to like the program test instance, yada, yada. I'll show you how simple this is. You also want to create a list of accounts. I don't really think I need to do a back. I can just do like slice and I can just say like account new. And we said that the program is expecting this account to already be allocated and assigned. And if it's not, we're going to get back this error. Okay. So what we want to do is first we want to test like spoof of it. So we're going to say like, all right, let's give it, I don't know, like 1,000 lamp torts. Let's give it enough space, which an order is going to be 16 bytes. So we'll give it 16 bytes. And then instead of giving it to the owner, so it's already allocated, but it's not going to be assigned, which is the check that we added. We added the ownership check. So let's assign it to like some random key that we don't know. Okay. And then let's go ahead and see if we can ensure that this actually returns the error. So here's where, this is how you write an actual like invitation that you can test. So you can just do process. And there's a couple of different APIs you can use: process instruction, process invalidate instruction. And then there's like what I call instruction chains, which are not transactions, but just like sets of instructions. But let's use the one that is most intuitive for tests. That's going to be process and validate instruction. And that just gives you like an API to work with if you wanted to apply different checks.
How does this one differ from just the process instruction call?
So if you do process instruction,
Mhm.
you just don't have this extra argument.
Okay.
So this right here is all you really need. And then this will give you a result, which you can do whatever you want on it. And you can see that the type is instruction result. And I'll show you what's good. So you can just like run your own checks on this information. So you can check the compute units, This one I wouldn't really get too focused on. It's not the most reliable metric, but the results and everything else you can't, including the return data. So if you want to write your own custom checks and everything, you can do that. And that's what this is designed to do. But if you wanted to also do some validation, I wrote a nice little like checks API for you that lets you do some of these things on the fly. So you don't have to like actually do anything with the return value, even though it still comes back. It's the same return value, the same return type. You just don't actually need it. And I'll show you what the checks API looks like. So you just do like this results check. And like I said, you don't have to use this, but it gives you this nice little syntax here. And we said we wanted to make sure we get a program error, and we wanted to make sure it was, I think I need to add this import. What was the error that we wanted to look for? Invalid account owner. And you can just put it here. And then like this little thing will automatically run a check for you. What is this yelling about? Oh, I forgot. Okay, so your accounts are supposed to be a tuple of the public key and the account. That's what it's expecting. But like I said, everything's a slice. And then that's it. Like that's literally a test.
Wow.
And so like zoom out real quick, you can see that's literally a test right there. So you can do like cargo test SBF and it'll build out and then everything will break because I must have done something with my program. What is this? I forgot to do this. Whoops. This will probably give us some warnings, but I'll fix it later. Okay. And now while that's running, like we can marvel at how small this is.
Yeah, it definitely takes away so much setup that you have with like other testing frameworks. So super straightforward.
Yeah. Yeah. I mean, there's no more like program test setup, which isn't like the hardest part. The most annoying part about program test was like right here, instead of like declaring a slice of the counts, you would have to do like program test dot store account. You'd have to do like a bunch of state setup first. And then you'd declare an instruction. And then you declare a message and a transaction. And then you'd apply signatures. And if you're missing signatures, you need to make the sig verify step happy. When in reality, like you're not trying to test whether or not the runtime will verify your transaction. What you're trying to test is if your program does what you want it to. So like you can just not do any of those other things that you know like Solana is going to do because those have their own tests, right? Like the runtime has its own tests for making sure that malicious transactions can't get through and that all the signatures that are declared are expected and that are applied. So like you don't need to test that in your program repo.
So is this
Let's see here.
removing the need for sig verify when you're using Mollusk? Like it's kind of taken out of the testing.
Yeah, yeah. It's completely removed. So like I'll even show you what it looks like if you run this test. Like if you go and drill through this process instruction, this is this is literally what the harness does. And all these steps come directly from the agave validator. So like it's gonna figure out which program you're gonna execute, whether it's a precompile or if it's an SBPF program that's cached. And then it will go ahead and compile the accounts that are in your instruction. And now here we have to mock out a transaction because like a lot of the runtime stuff exists in the context of transactions. So we have this transaction context, even though there's only one instruction. And then it's just going to convert these like components into their like agave counterparts of the program cache, the sysbar cache. And then it's going to just create this invoke context, which is what the VM takes as an input. And then it's going to just either process the precompile or process your program and then just like return the information. And like here, I'm just like grabbing the return data, I'm grabbing the resulting accounts, and then I'm giving you the result. That's it. There's really nothing else to it. because this is as low as you can go to invoke the VM.
So I guess just like for more context for people that are watching, I know we have a lot of examples that are using like bank run testing, and bank run is just using the bank server and the bank's client, and that's it. So how does that kind of compare to bank run?
Yeah, so like the bank run and now like the light SVM and some of these more, I don't want to call them large because they are quite small and they're significant improvements over program tests. But what they're designed to do is they're designed to give you a minified runtime. And that could be really useful for a lot of scenarios, especially integration testing. But the biggest benefit of a minified runtime is you get state persistence. You get more like cluster wide behavior that you can configure for your test environment. Uh, So, like, to give you an example, like maybe you want to run a few transactions that like initialize some pieces of your protocol, and then you want to like do some transactions that your users might do, and you want to observe the broader state of your program as it evolves over like a more robust tests environment. Mollusk isn't going to be the tool for that because you're going to have to constantly give it new accounts every time. Whereas like the light SVM or the bank run stuff, that stuff is already there. And that's what program test did too, because the runtime does account commitments and it also updates, like it does the whole process of moving from one bank to another, like the whole like parent bank to child bank transition. And that includes all of the updates to stakes caching, rewards distribution, account commitments, and all the things in between. And so none of that is here. This is just like input, output against the VM. And so it's really designed for like unit testing. If you want to unit test a program and you want to just make sure you have really good coverage on each instruction, this is going to be, I think, the superior tool for that. But there's other reasons you do see other ones.
Okay, that makes sense. So when you're focusing just on like the smart contract level and wanting to do a bunch of unit tests within the smart contract that you're creating and kind of iterate on that, Mollusk is going to be like straightforward and very simple for that design.
Yeah, exactly. Like what the way that I usually do this, because we use Mollusk a lot at Onza, is like I'll literally go like this. To be honest, I'm usually flipped around here, but I'll take my processor and I'll say like I want to run a check. And so I'll like add the check and I'll say like data, I think there's a field for data lang, and I will say like is not equal to, and then like I'll add the check and then I'll go over to my Mollusk test and I'll just go ahead and like create another test and I'll just like tweak it. Right. And so I'll make this like 12 and I'll make this the program ID and then I'll make this invalid account data. And so as I'm like adding checks to my instruction, I'm adding tests. And so I know like line by line that I have coverage. And then I just keep running them. And I make sure that things don't break, which as you can see, I forgot size of, I swear I've written a million times.
Let
Anyway, you can like see that you have the test coverage that you need. Right.
Yeah.
And that's like how I do program testing. So that's why I kind of wrote this thing.
Yeah, no, that's huge, especially like you said, like line by line coverage. Like as you're like updating and iterating your code, you can just constantly check it and make sure you have those tests done. So it's a great way for just like test driven development. I like it.
Yeah, 100%. Yeah. And like it's pretty nifty too, because like there's a lot of people that I'm sure you know are like really getting into the whole like CU optimization side of things. And so like if you want to do something like this is the expected, we've got enough space, we got the owner. So this becomes a check for success now. And what you can also do is you can say like, I want to make sure that we have enough compute units. So like I want to make sure my program is like, I don't know, what's an ambitious number? 150 compute units. There's people that are going to scoff at that. So then you can test it and it'll tell you like, oh, you don't have 150, you're using 349. And you're going to go, what? 349? Why? And then you're going to make some changes to your program and you're going to see how low you can get. Or you're going to say, all right, 349 is good. And you're going to make sure that you don't regress on that.
Yeah, that's really cool. I know I was using Mollusk when I was testing out, like, comparing Pinocchio to, like, this, Solana SDK, and, just, like, with each test, it was showing the compute unit difference, and it was, like, very easy to just have it displayed on the screen, so definitely trying to push for compute unit optimization, so this is kinda puts it right in your face, which is good.
Well, check this out. There's actually a nice, I'm not going to go through the live coding for this, but for some of the programs that we wrote, like we converted a lot of them to BPF. And Mollusk actually has like a bencher that will do compute unit profiling.
Oh,
So if
that's
you take a look at these, what's that?
I just said that's cool.
Oh yeah, if you take a look at like these bench tests on the address lookup table program, like this is just like some setup that creates a bunch of test cases and creates like a bunch of just we're basically just creating like mock-ups of each of the instructions and like being able to like spin up a bunch of them. And then this is the bench right here. And you can see like we create a Mollusk instance with the lookup table program. We warp it to this test slot because that's specific for like the lookup table program. And then we create this bencher and it has this like little builder setup. We just add a ton of benches. You can determine whether or not they need to pass. And then you can spit out the regression test to like an output file. And then we commit it because it updates itself.
Oh, wow. Yeah.
And so like at the beginning, these are all new. And so we're testing like how many lookup table addresses are being like added to an extend or whatever. And you'd see it's like pretty damn expensive. But then we make some changes to the program and you run the bench again and like Mollusk will update this file and it'll like, if you have your like workflow set up in a way that you want to commit this, it'll tell you like, hey, you have state on stage changes and you just add this. And then with each PR, you're getting a delta on CUs as a result of whatever change you just made.
Wow.
Actually, I have to shout out Anchor because I stole this directly from Anchor. Like this is literally what they do with Anchor. I just stole it.
It's already
Handed to our money and Edron this idea, but it's pretty sick. I think people should use this.
So if someone wanted to use this, like, in their own workspace, like, how would they do it? Just
Which one? The bencher?
yeah.
You're talking about the CU bencher?
Yeah.
So the way that we set this up for the lookup table, this is I recommend doing it like this or something similar to this. Basically, you add it as a dev dependency.
Okay.
Wait, sorry. You add it as a dev dependency for your program, and then you just create like because it's a separate crate. So like Mollusk is pretty modular. So I try not to load everything into the same crate. So you add the new dependency, and then you create this benches directory, which is like a known directory to Cargo.
Mhm.
And you also need to create one of these because you can have like multiple benches. And once you create one of those, you write your tests in here and Cargo knows to like invoke this compute units bench. And then all you do is just write this bencher new and you'd use the builder model to like build it all out and add a bunch of benches to it. And then this final like execute call is just going to execute all these benches. And the reason, like, technically you don't need this bencher struct at all. Like you can just write like a Mollusk test and you can have it use like a different, like you have like ranged inputs and stuff like that. And you can write like more true bench testing. But this little struct is designed to just like take all the results from all the benches that are in this thing and like wire them together into this nice little markdown file and give you comparisons on CUs. That's why it's called a compute unit bencher because it's focused primarily on this. So literally this file is like all you need.
Okay.
Like however you want to like write your tests is up to you. And it will write you this full this file wherever you tell it to. And then you just get this for free. And these are just the name of your bench tests.
Oh, that's perfect. We'll
Like if you look at some of these setup functions, it'll tell you.
awesome. We'll include a link to this example in the description of the video, so everyone can check that out also.
Yeah, I think that'd be sweet.
Cool.
Yeah, there's a lot of like functionality in here. If anyone wants to take a look at the repo, go right ahead. It's getting a little big, but you know, Like it's not too bad. The harness itself is all you really need to test a program. And it's built on some of these other crates. And if you wanted to like use SPL token, like these ones give you the elf. So you can like load the token elf into the Mollusk environment without having to like go fetch it from the chain. There's some helpers in there for you. And then there's some fixture stuff if you're into fuzzing, but it's a little complicated. And some of it is like work that we were doing with BioDancer to test different programs. But if anyone's interested in that, definitely,
Cool. It's awesome.
yeah, yeah. So like this is like pretty sweet for writing program tests. And one new feature that we have, like there's a lot of cool stuff I could show you. Like if you wanted to do, like I mentioned earlier that like some of these other test frameworks are better if you want like persistent account state. Well, you could do something like this and you could say like, I want to have an account store and you could just have like a hash map of key account. And if you wanted, you can also take like, I forgot if I made this without create it. Pretty sure I did. Maybe I did. But yeah, you can do like a cow store and you can my cow store. And you could just like implement this trait. And then I'm not going to fill these out, but what you can actually do is you can say like, let mollusk on steroids is equal mollusk. You can say with context and you can say account store. So do it. Yeah, there you go. And now you get the same API. But if you look at like process instruction, you don't need to give it accounts anymore.
Oh, that's awesome.
Just need to give it the instruction. Yeah. So you can like pre-fill this little like store. And then as you process instructions, it will update it. And so you can get some persistent state.
No, that makes things a lot easier, especially because depending on how complex your code gets, there can be instructions that have quite a lot of accounts. So, um, definitely makes it easier than having to write them all out explicitly.
Yeah, I totally agree. One thing that's cool too is like if we wonder if I could demonstrate it in this video, but like recently had a release for Mollusk that introduced a new feature for like testing custom syscalls. And this is a pretty cool feature where you can like register a syscall that you wrote and you can test it out. And so like, let me see where I wrote this syscall. Okay. So I have like a program and this program is going to call this like syscall that I created. So I'm just going to create the binding and I'm going to register it in my program binary. And even though the platform tools don't like do anything with this when they compile your program because they don't know what the symbol is, Mollusk actually will still let you get away with it, and you can still build it. Surprisingly, you don't get a like a link or error.
Oh, it's awesome.
So you build this out, and you can define a syscall. And I just wrote one that looks like this, and it just burns CUs. And so, like, you define a syscall, and then like because you're calling it soul burn CUs, right here, you can say, hey, like register function, soul burn CUs. It's the custom one that you wrote. And then later when your program calls into soul burn CUs, it can call into the syscall. So you can test your own syscalls.
Yeah, that's awesome.
Yeah, it's pretty neat. Yeah. I mean, did you have any other questions about the harness? Is there anything that you wanted me to dive into at all or write some more of or anything like that?
Oh, maybe go back to just demoing the example, just to kind of walk through like what's actually displayed in your terminal once you because we kind of got a little distracted chatting after, but
Oh, yeah, of course.
Yeah.
I like to have my terminal on the top. So some people, it's been a while since I put it down here. Some people, I think, they prefer it down here. It's maybe a little more clear to have it right here. See if the log's looking better. Cool. Yeah, what did you want to know about the output?
Yes, we can just see, like, it shows, like, the compute units consumed, and then where the actual, error comes up, the account failure, if you wanna scroll up. So you can see all of that comes out on the console, and then it shows that the test passed. Yeah.
Yeah, that's right. Yeah, so like these are the logs that you're always going to get as long as you have the logging enabled with whatever test harness that you're using. These just come from the program runtime.
Yeah.
But basically, yeah, you could see the error codes being thrown. Like you can see the string messages being thrown because, the program we set up to like throw the error as a string output before it fails, but we also get the return code that reflects each of these error types. And we're testing them right here, right? So like we're making sure that this is the error that's thrown. And then finally we want it to succeed. And what we didn't do is we didn't actually do anything to like write the account data. So I'm going to just say like, I'm going to go steal this from the instruction one because I know I did it already over here and I don't feel like writing it already. So I'm going to do this. I'm going to re-implement this code in like 50 places.
Nice.
So we'll just go ahead and like write this data. This is gross. Don't do this, people. But yeah, should do it much more safe than this. We're going to assume this is 16 bytes. And then I need to also take these inputs. No, it's ask and size. What I'm trying to demonstrate here is like once you start like working with account state and you start actually like modifying stuff, you can actually test that as well, which is pretty neat. And there's a nice little API for that as well. See if I get any compiler errors. I bet you I screwed something up. So the first of all, the compute units are going to change. Yeah. So what did I forget? Extend from size. More. This should be ask. Okay. Okay. So compute units obviously went up a little bit, and we're going to go ahead and update those to reflect our new setup here. And I don't need any of this stuff anymore because I already showed you that we can use that, but we don't need to use it right now. And so now that we know compute units went up a little bit, we also want to make sure that our program did what we were expecting it to do with the account state update. So again, this is like stupid, unsafe, but it'll work. And basically we want to make sure that these fields made it in. So I want to just take these as variables and I'll just say like, I want the ask price to be, let's say like 2,000 lamp ports. I want the size to be whatever this like token we're using. We'll just make it size 100. And so now we can like, get rid of these things. And now what we want to do is we want to add a check to make sure that our account state was updated to what it was expected to be. And so we'll go ahead and do like check account. We want to check the order. We want to check the data. And we want to make sure that the data is, oh no, Rust is cannot let me doing this, but I think it will let me do it. If I do this, I can probably use the same code. Yay. Oh, Okay, so anyway, we'll make sure that we pull this up. So you can just say like let expected data, and you can just like return that. And you can say like, oh, you know what it will let me do? I'm pretty sure it will let me do this. I think it'll let me do this as long as I just put the reference up here. Yeah.
Yeah, this definitely takes out a lot of code when you're wanting to check account state after testing a any type of instruction call. Like, this is really simplifies things, so
Yeah. It's so nice. And so now you can see like as I showed you earlier, I added this new step to the program and immediately added a new like check in the tests.
Mhm.
And you can see that we know we're getting the same exact result as we're getting as we want to get the program. And so that's pretty neat. And I'm not going to bother doing this instruction because it's kind of the same to get the gist.
Mhm.
If we have time, I might run through doing a syscall because I'm curious to see if we can do syscall that will give you the spread on
Yeah,
this order book.
let's do it. Let's test it out.
All right. All right, cool. Then let's try it. So I'm going to grab the repo just to look at like a reference example. So for anyone who needs this feature or wants to test something, um, I recommend just looking at the tests. So I'm going to pop open this test programs in one tab, and I'm going to open the harness test for custom syscall in this tab. So you can see there's a custom syscall test and a custom syscall program, and this will show you how to do it. And it's pretty straightforward on the program side. The test side is where I think this is going to get a little tricky because what we need to do is we need to figure out how we can declare this built-in function. Oh, we can reference like state that is instantiated in our test environment. So I don't know. We'll see if we can do this. So yeah, we were talking a little bit about this, but like one feature that we added that I think was pretty cool is with the 0.2 release, we added the ability to do system calls, like custom syscalls. And this is pretty neat because it lets you register custom syscalls and like test them against the VM. And this is kind of tricky to do without like a harness that helps you. And it's even not that easy to do with Mollusk, but at least you can do it. And maybe we'll iterate on. I think this is what I did with one of my tests. So I wrote this syscall that just burns CUs, and it looks like this. And this is just like the macro that the program runtime gives you for like creating a new syscall that has the right interface and stuff. You don't have to use it, but it makes life a little easier. And you can see like this is the stuff that's available to you. So you get the context that the VM gets, and you get some memory mapping. And this gives you the mapping between the host and VM memory. And so this syscall I wrote for the test is just going to burn some CUs. So it's just going to consume it. And then you can write a program that will actually call into this. You just create the binding and you register the function with your like your compiled elf. And the compiler doesn't really know what it is. It just kind of like looks past it apparently, which I'm kind of surprised that doesn't like throw an error, but it looks past it. And then as long as you've got this function registered with the like program runtime environment within Mollusk, then you can use this. And so I'll show you what that kind of looks like. But if you ever wanted to check it out, you can just look at the tests and you can look at this custom syscall test and you can go ahead and see all this stuff in here. And then you can see the implication. And we're going to do this. So I did some of the setup already, saved some of the time. And basically, should uncomment that. Basically, like we saw what it looks like to just do like these normal instruction invocations. And I wrote this other instruction here that is just no account, no input data. It's called check spread. And I just got like so the helper to give us that instruction. And in the function itself, we're going to check the spread using this syscall. And so we got this new syscall soul check spread. And my like pie in the sky idea was that you could write some like implementation in the test, which I didn't have time to do for this video, but you could like spin up a bunch of accounts. You could have some state stored somewhere. And then you could register a syscall that can like access this state from the host. And that way, when your program is executing, it can like grab this information real time. But since Mollusk isn't like persisting state or anything, I felt like it was probably not really necessary. And it's probably a little overkill anyway, but it might be cool to mess around with. Somebody wanted to try it. But that's what like all this crap is I was going to basically try to create a bunch of accounts and use those in real time. But sorry, don't get to see my party check after all. But anyway, so here's where you actually can create a new syscall. We use the same macro as the one I showed you in the test from the program runtime. And you get access to everything. Oh, I remember why I had this comment out because I always forget to set up my analyzer. You can get everything from the invoke context if you wanted any of this information to write a syscall. But we don't need it for this one. What we do want to use though is the memory mapping, which gives you an API for working with the virtual and host memory. And so all I'm going to do is like, here's where you can implement some custom logic to like get the value of your spread. And then we want the program to give us the pointer in the VM memory. And we want to map it into, a pointer that we can use locally that we can update. And then we want to just like write to it. And so we're going to just write this spread value to the pointer. And this could be dynamic somehow, but in our case, it's just going to be static. And so here's like the tricky part. I think I could probably work on this API in the future a little more, but for now, you need to make sure that you register the syscall with the program runtime environment. And then you have to do that before you add your program. Because if you don't, your program is going to get compiled and verified, and it's going to get put into the runtime environment before this function is part of what's called the function registry. And that's just a list of all the available functions that your ELF is going to be able to recognize. So there's these things that happen when you compile a program that are called relocations. And right now, syscalls are dynamically relocated. So like when you add a program to the Mollusk environment, it goes through the same verification process that like a normal program deployment goes through. And so if you try to call into a function like this one, which we've named sol check spread, and it was compiled before the sol check spread was registered with the function registry, the runtime is going to give you an error and it's going to say, I don't know what you're calling. It's not supported. And so it's really important to make sure that you just go with the default instance, which has no SVPF programs, register your syscall, and then add your program. So kind of a foot gun. But as long as you do that, you should be able to use your syscall. And then for our program here, we're just going to like take no inputs. We're just going to say like initialize this value to 0, run the check spread syscall, which should update the pointer, and then go ahead and print the new spread value that we get from the syscall to the console and to the logs. And just start invoking here to make sure that we do get a success. So let's go ahead and see if it works. Actually, I want to make sure I do cargo test SBF. And I want to just run this test. I don't want to run the other one. So we can get some more up. And there it is. Spread is 420.
Awesome.
That's the custom syscall right there. But yeah, so you can do that with Mollusk if you want to. And there's a ton of other stuff that is interesting in there. I encourage people to explore. But yeah, the syscall one is neat, I think. It's a little bit of a pain. I even struggle to work with this API. But once you get used to it and you get familiar with it and you get more comfortable with working with memory mapping, you can really get pretty nasty in here and you can do some pretty crazy stuff.
So just to give like some more context for people watching, what are a few examples of like why you would want to write a custom syscall? Like how would that kind of help you out?
So I think one of the reasons I added the feature, I think I had like two reasons in mind. So one of them was to test syscalls that we were like already planning to add or change. But another one was mostly to give other developers the ability to test syscalls that they might want to propose as like a SIMD. So like if you're interested in a syscall that might give you like the transaction signatures or like just some other information that you can obtain from that API that I showed you, then this is a really good way for you to just like prototype it without having to pull the whole Agave code base down and like deal with all the dependency crap and like figure out all these different intricacies between crates. You can just like do it with Mollusk, get it working, and just be like, oh, okay, this is kind of exactly how I want this thing to work. You can shortly iterate on your interface, and then you could write a good SIMD and, or even just like a discussion to start. And you can try to get this thing supported and you can talk more about it from like a very technical aspect because you have already prototyped it and it was kind of easy to do.
Yeah,
So I
definitely.
think that would be pretty sweet.
Makes things, like, a lot more straightforward and being able to kinda test out, like, exactly what you wanna implement before you propose the idea. It's awesome.
Yeah, exactly. I think that'd be sweet. It'd be cool to have like other people be able to propose ideas for syscalls.
Yeah, definitely. That's really great. And it's a lot less intimidating for someone, like, if they have an idea, they're like, "Oh, I can prototype it, test it out," without getting very overwhelmed with all the dependency issues that may come up or other things that they have to understand to be able to test out their idea, so
Yeah, I think anytime you could avoid like using the whole Agave code base for something, you're like a lot better off because it's a pain, especially if you're trying to like test something that's at the lowest level of the validator. Like you don't need any of the other stuff. You want to test something that's like just going to talk to the VM, like you can do it.
yeah, that's awesome. Yeah, it definitely simplifies things. It's great.
Yeah. Cool. Well, I hope people find this useful and they want to test their programs with it. But see.
Yeah, definitely. I'll keep you updated with any, like, questions, comments, feedback that we get and see what happens, so, yeah,
All right. Sounds good.
cool.